Hello, this is Introduction to Drawing Your First Still Life. Classical Art Education Center is a Blue Ridge Academy's approved vendor. In previous lessons, I already covered proportions and measurement, three-dimensional structures such as cube-like structures, cylinder that is vertical and on its side in three-dimensional space. I also covered introduction to values. Now we're moving on to our next lesson, which in the Russian academic curriculum follows all the previous ones, which videos I already released. This is the first drawing of your still life. If you are jumping straight to still life without those previous lessons, you will struggle in this lesson. To minimize your struggles and achieve that accuracy in drawing, I suggest you review those videos and do those exercises if you didn't already. If you did all of those and you start watching this one and you see a mistake that I make in the first phase of drawing the still life, then you definitely aced it and you will be ready to move on to the next lessons. If you didn't notice the mistake, it just means you need to go back, review the lessons, and practice a little bit more before moving on to the next phase. Don't forget to like, share, and subscribe. And now, drawing the very first still life. So technically this is a still life, and now you need to compose the still life. So now you're doing the beginning of composition. And the beginning of composition means you have to think about how do you do two objects on the page. So when you did black and white, it was still kind of like I didn't even talk about composition, right? So now we do need to start thinking about what do we do for composition. You know, I have to move. This is not good enough light. Okay. So my paper is slightly smaller, yours is larger, basically the same thing. Horizontally oriented rectangle, that's your window to work with. So you need to take in the whole page, and think how you're going to fit those two particular shapes, your cube and your cylinder. Cylinder on the side, coming out this way. Cube was standing sort of vertical this way. And so cube is taller than the cylinder. What else is going on? There's a little bit of the background needs to be included, a little bit of the table needs to be included. So we want to add all of this. How do we do it so it doesn't feel like it's too small and too much room? Because that will feel like too much area around it will feel off. If we do too big, you are getting too close to the edges, it will feel cramped. That's the nature of this window, right? The rectangular window into that new three-dimensional space that you're creating. If you get it too close to the edges, the objects will feel cramped. Now, it doesn't mean that this is a hard rule. And never ever do you ever cram your objects into your drawing.
Yeah.
Or make them so small that they feel like it's very zoomed out and, there's too much area. If your subject matter, whether it's a still life or anything else, portrait, figure, landscape, if you want the viewer to feel like everything is correct, if you need that feeling, you absolutely cram it in.
Yeah.
If you want to feel that something is very small and insignificant, you absolutely zoom out, do it in here very detailed, and leave all of the space. However, the degree of work you want to put in, less, more, and so on. It's all about the feeling. But as we're studying academic, traditional sort of that classic approach to studies, we first study how it is without any particular feelings attached, right? So we first want to learn to draw, construct it correctly, learn light and shadow. Feelings is another layer on top of it, and that comes later. So now that we got this out of the way, here's our rectangular window. If we approximately stake out, like working within window within a window, right? If we say there, we'll just step away from the edges And imagine that this already brings it a little bit away from the edges and helps us not to cramp it in. If we now start thinking about fitting it into here, how would we go about it, right? So just like what you did with the stylized flower, and just like what you did with measuring the proportions of the tallest to the widest of drawing objects, right? We're gonna do the same thing to the entire still life. So here is just looking at the still life. So what we're going to do is we're going to stake out with the side measurement. This is obviously our furthest away to the left of the entire composition boundary, right?
Yeah.
This will be our furthest to the right of the entire composition. So this will be the width as if this was your one object. We're first treating it as a group, as one thing. And that is doing what? It's simplifying it and it's abstracting it. Okay. Then what is the tallest then? This is the lowest from your angle of observation. And then which is the tallest?
Yeah.
But this one.
Yeah.
From lowest to highest, you will be doing side measurement in this direction from that angle of observation wherever it stops, right? So you find that proportion, the two of them together. And so once we measure that proportion, which is what I'm going to do right now. So here we go, from side to side, and from the lows to the highs. It looks almost like it's 1 to 2. 2 wide and 1 high. Let me go and just go from that lowest corner to the highest corner of the cube. And compare that from the cylinder edge on the right. Yeah, it's very close. It's not quite, it's a teeny bit shorter, but it's almost. So for example, if I have this entire width and I compare this entire height, definitely can't be 1 to 2.
Yeah.
2 has to be here, 1 has to be here. But if I divide this entire thing in half, let's see, is this close enough to half and half? Close enough. So if this is my half, but I need an eraser. It's like my half of the page, my center, but it also looks like it can relate to the entire composition, right? Always keep an eye on what's in the center. That means that now I can stake out how far my cube will come out this way and my cylinder can come out this way. Definitely don't want it on this. It's too close to the edge. So let's stake it out a little bit in. Let's just say like, how about this? We are learning, we are experimenting, right? There's nothing's wrong with experimenting here. Let's put the cube in here. That's the edge furthest edge. So that means this is 1/2, this is the other half, right? And I said it was almost, right?
Yeah.
It was the kind of almost that my cube, my first half came here and my cube was a little bit short. This is how I measured with the side measurement. I had a little extra tip of the pencil go beyond that, all right? But that just means that this definitely gives me the entire height now. So now that I have the height, I can decide how low my cube will come down here and how high it will be over here, right? I know it's going to be this particular size. I'll go upside down. It's going to be like this. Here's going to be my cube. And the rest is going to be my cylinder. But now I need to decide this way, right? So as you see in a lot of regular classical still life, they leave some space above kind of like the air, so there's enough room for any other additional objects that want to just go up vertically very thin or something. And they usually have the edge of the table in some way in here, and then the objects themselves, right? So there are two ways you can go about it. You can say that you will have a very close to the edge table. This is kind of approximately where our table is. And then you can look and see how far from that edge of the table your actual cube is. And it's not very far. And like the edge of the cube is probably in here somewhere. So if we indicate it right in here, you look at it and go, this probably is close enough. I may want to move this just a little bit lower. But this seems like it's good if you imagine that this is the edge of the table. Then the cube will be touched down here. Then the rest of it will come up somewhere in here. And the cube also spreads out a little bit on the other side of the center, because when I was measuring, I already saw that. So that means the entire cube will occupy this space if we just abstract it without our three-dimensional thinking. All right, so we abstracted it and dedicated this entire square space for just our cube. Now, I mean, slightly less than half is left for the entire cylinder, which also means that we can find the top angle, we can find the bottom angle, and right now I'm only sketching it like very, very sketchily, approximately. It's not gonna come past this place, right? It's not, definitely doesn't come down as low as the lowest portion of the cube. So it's not gonna go beyond this. It's gonna be slightly higher. By how higher, we'll adjust it later, right? But it's definitely gonna be lower than the highest portion of the cube. So that's why I'm throwing it right in like this. Not counting, not doing any proportions yet, right? It's completely not necessary. We just want to now imagine how this will feel overall on our paper. How does it feel? We have all of this space here, and we have this space plus a teeny bit more on top. It's not totally equal, and that is good. We don't want it totally centered. We have this space here, and we have this and a little bit more here. That's also good. That's a good sign. So that means we now can think about how to do it more precisely, and it will be all nice and balanced. The only thing I can say is that we also will be adding the background where the flat table meets the vertical wall. There is a mild change because I don't have a deep crease in there in the fabric, and that is also very minor, but you can kind of imagine that if the table is here and the table switches somewhere in back of the cube over here, so it's going to do something like this. Is it coming through? Yeah, it's coming through near the top of the cylinder. So if this indeed is our position for the cylinder, it's going to be here and it's going to be lower here. It's going to do something like this. And therefore this table, let's now lower just the tab as well. And we will want to see a little bit of that perspective. So this is a little steeper, this is a little bit less. But now we're getting ahead ourselves because we now need to see the actual angles, right? So here's our total space occupied by your two shapes. How does it feel together? Does it feel balanced? Here's our center. The cube is massive, more massive than the cylinder, and it comes over slightly to the side of the center. Majority of it is on this side, so the weight, we feel the weight here. That's a heavy weight here. slightly less weight here, but also the cube, part of the cube's weight goes past the center, so it pushes here as well. Plus we add in the cylinder. Plus it is going in away into perspective, so it's becoming slightly lighter in a way visually only, because things are getting smaller in this direction. Smaller / lighter, not by actual weight, but by feel. All right, so in that way it seems fine. The only thing we could do is if we felt that this is a bit too massive, is to shift it just a little more, so a little more of this big mass goes past the center and move the lighter cylinder a little closer to this boundary, right? So let's do that. So we'll just shave off the exact amount. So if we shave off here, like this 1/2 inch, we add 1/2 inch here, right? So that means that this also shifts a little bit more. So basically it was this, now it shifts to here. Now this goes away, center stays. The entire cube shifted, the entire cylinder shifted, and this about stays the same for now. So how's that for balance? How do we feel now? Yeah, a little bit better, right? Yeah. So it doesn't feel too heavy on the left and feeling like it's going to tip over. Here's our center, right? Yeah. And that's how you go about it. And you can always do a small sketch in the corner and do exactly this thing and figure out big weight, less of a weight, how do I feel about it compared to the center, right? What if I shift it over and shift it over? So again, this is also not a super hard rule. This is for you to study, so you don't have to worry about the rest of the balance issues in your own composition. Once you are fully trained and you do want to feel in balance, viewers need to feel in balance in your work, or there is some kind of other balance that you're introducing, like in the Japanese ink paintings, where they have like a whole bunch of very elaborate branch on one side, maybe a little bird, and then the rest is very airy, maybe just a little mist, maybe something very distant, just indicated like an outline of the mountain. It has that heaviness on one side, and the other is nearly airy, very atmospheric, or nothing at all. There is a whole other balance and a whole other feeling that goes with it. We are not doing that. It's not to say that Japanese are breaking rules or we are breaking any rules. It's just this goes with the style of academic studies when we need to learn and focus on creating a decent drawing with certain rules observed so we could practice and become like strong at those rules. All right? So now we can go ahead and stake out our cube and cylinder a little more precisely before you start doing the main construction. So I'm going to measure the side of the cube that is most visible, the biggest side in the direct light compared to the side that is in the shadow. And it looks like, it almost looks like the entire width of the cube has a proportion to where the side that is in the shadow fits in here once and almost twice, but not quite, like 3/4 almost. So I'm gonna stake this out. I am breaking everything that's in the light and everything that's going to be in the shadow from each other. So separating those. Okay, I've separated those. Let's straighten out this line now. Now this line is a keeper. We're keeping it. We just need to figure out proportions within. All right. This line is a keep. Keeping that. So now we need to figure out a little bit more precisely how that side of the cube and the shadow related to the light. So I'm measuring again, make sure it's more precise. Yeah, I think I did a pretty good job here. Let's see, it's this line to here and to here, and that little tip goes past. So I like how that looks now. Okay. And that gives us what? It gives us this closest to us side of the cube. Bam. So now we have our first intersection from which we're going to start judging where we're going, all the directions. So now it's a plane like lining up your pencil with this side, bringing it here and getting this direction. The closer you get this, the better it is going to be for your perspective. The more convincing your perspective is going to be. So I'm going beyond already, beyond our object, into that three-dimensional space to say that vanishing point is out there. Now you can also obviously, you know your eye level is way above this still life. Because you've been doing this angle of observation for quite some time. It's just, this is set up lower. So, you know that your eye level is way out of sight here, doesn't fit. So what you can do to get everything right is to find that proper angle, double check, that looks good, and this angle. And then as you construct these distances compared here, it's going to be more, here it's going to be less for shortened, and less, more for shortening here. Once you get those, because you can easily see, right, all the proportions start coming into play. So what you can't see, like the back wall, you know, that you can figure out because you know how to construct. So now I'm going to get the side of the cube the other way, in the other direction. Okay, going in this direction. Okay, and now we can do the top, same thing. The top closest to us. One other thing, where if I do the top now, I'm going to be guessing where it's going to go, right? For you need to measure, because you're not too good at guessing yet. You can first guess, and that's good, and then measure. What am I measuring now?
The length.
How much of the top plane of the cube I see, right? Compared to that closest to us edge. It seems that the closest to us edge compared to, I'm just going to put in my first guess, compared to how much of the top I see, compared to this distance, fits into here 3 times. The way I sketched it now, will it fit 3 times? Let's see. 1, 2, 3. Too much left, right? Let's lower it. We're lowering it. Now we go from, and see, I'm already guessing that my other corner is going to be here somewhere, right? That's why I'm going like this. So this is one measurement. Okay, here's 1. Here's 2. And here's 3. Very good. Keeps. Is it super precisely 1, 2, 3? Maybe, maybe not. You can never get it super precisely with this measurement like this, in the sight measurement in the air, right? But you can get close enough. Close enough will work for what we're doing. First, you need to get close enough, but the more you practice, the more precise you get. You train your eye. But if you don't stake out this proportion, you're just totally guessing, and without enough experience, it's guessing in the dark. With guessing and measuring, you calibrate your intuition, your visual intuition, to the actual measurements. All right. Okay, so now we have this intersection. And this intersection means we can go in this direction and this direction. Same thing. I'm going to carefully as I can, transport this angle. Well, looks good. So that means somewhere in here. And I'm going to connect this too. Right, and it goes beyond as well. So if I look at this and I bring it way up, ta-da, perspective.
Yeah.
See? It opens up, means this is more, this is less. That's good. And it's not too extreme. That's good. We don't want it too extreme. This is not a building on the street. We're not looking from a 5th story down. So that's good. So now we're gonna go somewhere in this direction. Let's get this angle. Again, as close as I can. There we go. Looks good compared to the downstairs. This one.
Mm-hmm.
So, okay. Looks like my first guess was a bit too extreme in that going down. Probably shouldn't be quite so strong. Alright, so now let's take this one, bring it up here. Yay!
Mm-hmm.
A bit stronger than on this side because this is a stronger turn. So it's exactly the same measurement of the side of the cube, except it's going away at a stronger angle. It's turning away from us at a stronger angle. So now this is our front of the cube, and this, and this, and this. If you can do it all with harder pencil, so you don't push too hard and make it too dark, that would be super. So now we have this intersection here, and this and this. That means we can construct the rest. Let's do the same thing. Transfer the back angle, the angle of the back, just like that. That's nice. So when I transfer it, what do I do? How do I know I'm doing it right?
You compare it to the other.
Whatever the marks on the paper, right? I already had this kind of mark that sort of formed the cross. And when I lined up the pencil with the cube side and I brought it here, lined it up with this corner, I saw that it went right through that cross. And that's what I aimed at. Whatever the marks you already have, any other things on the paper, go ahead and utilize it. Now let's give this a bit straighter look. Alright, so now let's compare this to that. Let me make it longer. Here and there. See, it's jumping up a bit here. So that means I would like to make sure it comes down a bit lower, like this. So it's like it's a little archy on my line, and it starts to distort the view of that perspective. Okay, now don't want anything too archy. So now let's compare that, make sure the perspective is working. A bit longer compared to here. It's almost. The distance between here and here, for example, the linear flat observation distance is very tiny. That means the drop for that perspective is going to be very tiny as well. It's not going to be nearly the difference between here and there, not nearly. If you make it too much, it will show later. You'll struggle to make all of these parts meet. So all we need is that tiny change. Okay. Now things are starting to add up better. Okay. Let's go in the other direction now. We have this intersection and this, so we can now bring that over. And it's gonna go somewhere in here. So connect them up and go in this direction. So again, now between here and here is very tiny difference, right? Between this intersection and that very tiny difference, which means that how parallel they are, they're going to be extremely close to being parallel with the tiny drop. So here we go, tiny drop, so they don't look too parallel. All right. And that is when you don't have your vanishing points within your work or not even close. Even if you had one vanishing point right off the page somewhere not too far, would be easier to guess. But you don't, and this is how you go about it. Now we got this intersection. Let's drop a straight line. And now we can see if the back wall of the cube is opening up enough, right? Just remember, from center that way, everything's actually for this cube, the center is more like over here. Everything opens up more. So we go from mild angle to more, right? So that means that this has to be narrower than the back wall. And you see the back wall is starting to get a bit wider, which is a good sign. So whether this is going to stay right here or whether it's going to move just slightly this way is still up for grabs. So now we're going to do strictly based on knowledge. We can't see those angles inside, right? But we can only go by what we know. And what we know is that a change from this point to this point is more significant than over here, right? So that means that this angle is going to be doing what? This is exactly parallel, like this. No, even that is already adding a bit of perspective. Okay, this is if it was parallel, okay? But we need a bit of a drop, right? Mm-hmm. Because it needs to get a little closer to this line, but it also needs to fit neatly before this one. If we drop it too much, it will be looking like perspective here, but no perspective here. Mm-hmm. If it goes too steep, it will look like perspective here, but not a reverse perspective basically here, right? We need to fit it neatly in between so all of them look like they're heading for that same vanishing point. So the rate, right? The rate at which they're getting closer together. So let's put in a line that is a pretty good guess. When I'm drawing this line, or let's call Whatch lines, I keep looking from where I am and where I'm here in between. And if I'm feeling like I'm dropping, I'm raising it a bit more. Alright, so what is happening here is that I'm looking at this right here, and it looks almost like half and half. Is it half and half here? No. It's a little bit more. Is it half and half here? It's even more, right? That means I've gone a little too high, right? Means I need to aim a little bit lower. So now if I aim a little bit lower, like this, how is going to be this? Better, right? So now we're getting closer to capturing that proper rate. And why do we need to even worry about it if we don't see that back at all? We need to worry about it because what we do see in here, our construction depends on it. We need to make sure that this cube is constructed completely correctly. If we are off, remember how I said this is still approximate, it can move a little. If we're off, it's not gonna look right. And to make sure we're not off, we extend all of these lines and we see how the perspective looks. Even if your lines here are fuzzy like this, you can still get a pretty good idea. Alright, so let's make this a little more sure it up. Okay, let's double check once again. Like here we go and here we go. That little bit of a space, that's good. And here we go, and here we go, more space. And here we go, and here we go, more space. So it seems that if we drew a line through here, we would arrive here. Mm-hmm. And that also fits with our perspective, which is good. What could be is that maybe it should be still just a tad lower. Maybe it's, let's see, if we look at it this way, maybe it's just a tad extreme. Maybe it should be just slightly less, right? But to make it slightly less, that means we have to lower this here and make sure that over all, like this, everything is just tad on the lower side. Okay, and then of course our lines, these lines have to be, you just have to be straight. You can't be bendy. All right, so more or less, now it's a little bit lower. And so now we can go and look at it like this. Fits and looks good. We got the correct rate. So now, if we drop this down and intersect, and if we connect this two, and this line does not fit within our perspective, then you have the harsh reality hits you in the face. Mm-hmm. Because that means these things weren't quite correct and not quite straight, but obviously, so we can compare from here to here. So that means this, if we bring it here, being exactly parallel, oh yay! See, it's not exactly parallel, mm-hmm. It drops, yay! So it looks like everything got constructed pretty well. If this doesn't quite add up, that's not the problem. You just start going step by step in reverse. What did I do that didn't add up, right? Where, like, one of the key places, you go here and you go, if I move this just a tad, because see how wishy-washy this intersection still mm-hmm. is, right? It could be like, where is it? Is it here? Is it here? Is it like right here? Looks like it. All right. But what if it's just a little off and then it can be moved this way or this way? That will change this intersection and how this inclines. And because these angles are stronger, that makes a bigger difference here. It makes less difference here and makes bigger difference here because we're looking down more and the angles are stronger. But it all worked out in this exercise. Okay, so now you got your cube constructed, so now you can feel good about all of this here. So definitely keep these dots, don't lose them until the end. You will start shading, erasing, and what have you, and they might start shifting accidentally, and then suddenly something doesn't look straight. All right, so now we can move on to our cylinder, and that's cylinder on your side. So you just did that lesson. If you want, you can pull up your drawing, right? And once again, see how it looks. So what am I going to do now is I'm going to find the position of the cylinder by lining up the closest to me edge of the cube and where the cylinder connects, where the cylinder has a touchdown to the table. And I'm seeing that it's right here. This is the touchdown. I'm connecting. I'm basically like by a line. Okay. Also, the touchdown is here, but this is a line at an angle. If my cylinder, it's because I threw this in already. If my cylinder is not quite at round, if I need to narrow it down, that means that the touchdown will have to shift, but not in this direction, but more like this. The touchdown for the cylinder has to be a line that is parallel to the edge of the paper. Very important. This direction merely gives you the direction of how far away the cylinder is from here compared to here, right? But we are also heading for our approximate sketch. If I decide that the cylinder, what I see, that elliptical, is more like this, right? Then I have to go right here, not right here. And as you can see, that means the angle changes, right? Mm-hmm. So this is still approximate, and we are going to figure it out now. So let's lighten this all up so there's not too much confusion, and we are not losing this edge. And we're not losing this line here. This is our touchdown for the cylinder, somewhere on that line. Let's even get rid of this. Okay, so now the top of the cylinder, we found the bottom. Now we need to find the top of the cylinder and compare it to something else. The easiest thing is to compare it to the rest of the cylinder that we see to this distance. So compare the width to the rest of the cylinder, right? So I'm getting this distance and comparing it. Okay, it's like a whole elliptical and a little extra. So I'm focusing on seeing this entire distance, the center, and if I move that off of center, that means this will be slightly wider than this. Is that what I measured? I think I had a little more space here, so I will move this just by a little. So the proportion of how much of the elliptical part of the cylinder I see compared to the body length is something like this before the cube overlaps it. So I stake this out now, which also means that the box, the rectangular prism into which the cylinder fits, will have these two edges. And the box will also be going with the edge of the cylinder in the same direction. So we can transfer that angle, but we'll get to it in a minute. So now I'm going to look for the top. Now I'm going to compare the vertical size of the elliptical cylinder. I'm going to compare it to the cube. Looks about like 1.5. So what I'm seeing is something like this. 1, and then there's another half. That seems like what I'm seeing. So I'm gonna take this proportion, I'm gonna bring it here, and I'm going to mark the very top. Now right now it's just a rectangular box that I'm looking straight on, no perspective, no nothing. It's just strictly for how that elliptical will fit into it compared to the rest of the distance. But that also means that basically this center is going to be the center. There will be a little bit of foreshortening. This should be a little bit more over the distance, and this should be a little bit less, the foreshortening. That means that if we go from here and here, from this point, in this direction, we'll get the proper perspective. Because, where's your drawing? Did we? Oh, I think I already put it away. Well, hold on now. So, here you go, and here you go. See those lines? They go to the vanishing point, and they correspond to the edges of your rectangular prism, right?
Yeah.
So this is our center. That means this is going to go in this direction, and it's going to be a very similar angle plus a little bit perspective to what we are already seeing on our cylinder there. So I am going to take that angle. I'm going to bring it here. And I know that it's going to be similar to that, like that. And I'm going to say, okay, so actually my sketch here is not that. For now, I'm going to just do a contact with this thing. Actually, now that I've put in this, if I get a pretty good angle on going in this direction for my rectangular prism, then I get my rectangular prism precisely in here, right? This is still approximate, just to start bringing your mind in a direction closer to constructing the box. Why is this line important, even though it's not the line that we need to keep? Because it gives us the direction, and we compare it to these lines. And now we know that the prism is not parallel to the cube.
Yeah.
Because if it was, we would see this.
Yeah.
Now we know it's a little off. That means that if it was fitting into a rectangular prism, it would be a box that is a little bit more open, so like this, but slightly more turned, right? Because of this difference. That means if we take this and turn it, we can kind of guess the direction for our box, and that will go through the center. And you see how this is off from those lines, right? And that is a good skill to have, to see that, to be able to figure it out, to not draw the cylinder as if it was exactly parallel to the cube. Because if you do and you copy the other angles, it's not going to add up. So I'm bringing it down here, extending it into the front, just to emphasize the difference. I keep erasing it. Yeah. Okay. All right, that's good enough. To emphasize the difference in angle. Why is that important? Now here's the edges of our rectangular prism into which the cylinder will fit. So that means now we can go in this direction, keeping an eye on that, right? That will be our rectangular prism. And why do we need that? Because if we don't figure out where the back of our rectangular prism is, and we draw the back where the wall meets the table and that turn happens in the drapery. We can draw to where the cylinder goes right through the wall.
Mm-hmm.
If it's too low, the cylinder will go right through the wall. And that's where, when I see street paintings of streets, and I see that these turns just don't add up, it looks like a car is like another second and it's going to drive through the building. But what the artist means is that the car is driving parallel to the building. But if this is not figured out, you miss. All right, so that means that the center of the for the cylinder here, it's going to be doing something like this too. A little lower. Got it a bit too high. All right. So we can now take this angle, and I'm not drawing it all the way here because now it is not really necessary. We just want to make sure it doesn't crash through the wall. And we can bring it here and see if the perspective is happening. Yeah, that's where this needs to be just a bit lower. And no jumping up here. Everything stays a bit lower. Here's our perspective, which is happening. All right. This is now close enough. We are moving on. We can take this out. It will perhaps line up with our future edge of the cylinder, perhaps not. All right. Well, right now we're not concerned. So we have this. Now we can bring it up here and drop it a bit, right? For that additional angle. Perspective. Are we dropping it a bit too much? Let's see. How is, for example, this for the cube changing compared to this? A tad more, right? But the cube is a tad higher. This is lower, and it's changing a tad less. That's good. I think it's a pretty good educative guess, so we can keep it. And you see again, all the lines go through, and you need to draw them through as much as possible. Not all the way through here, but to compare everything, see better, it's good. So now we have two good intersections. We can stake out going in this direction. Again, you can look at that. You can bring it here, and you can make sure that it's dropping. So the way I lightly sketched them, it's dropping, right? So let's do that. But is it dropping maybe too much? That's what we want to make sure. And I'm kind of stopping over here because it is slightly different angle than my cube, and it's still good, right? Because it is different turn, which is good. But am I dropping it just too much? That's what I want to know. Here's this turn, and here's this. Maybe, maybe not. Because this is a stronger one, and it's changing less. I'm concerned that I'm dropping it a bit too much. See, maybe it should be going a bit higher. Well, how are we going to compare? For example, we have the top of the cylinder, and we didn't transfer that yet. So let's bring that over. See? And it seems what? Too strong. This definitely looks too strong. So let's do it a bit more carefully. I'm going to get rid of that so it's not confusing. I'm going to take that. So you see, you don't want to overdo perspective either. You don't want to be too harsh with your perspective. So the edge of the cylinder that we do see is going to be doing something like this. I'm seeing it intersect here, and I'm bringing it a little past. Not to this one, but a little past. Because remember how we're still seeing a little bit of the cylinder past its terminal here. So for now, this is going to be a good guide here, good guiding line. Now let's see over here, what is happening here. I see that this distance is too short, proportionally, right? So that means that as we are drawing, we need to make sure that this angle is good. It's dropping, that's good. But perhaps it needs to be lower. Perhaps this proportion could still be further adjusted. Because if we get it too high, that means this is too high. So I am going to approximately draw a center of my future cylinder. Rotational center. No, a bit lower. Half and half. Right? So this will be my future half. And if I draw with the perspective that I already have here, making sure that it is the same rate, right? So I have this distance here. Let's do better. This distance here compared to 1, 2, and a little bit to this intersection. And then I have, let's take this distance here compared to 1, 2, and not quite so little bit. It is possible that this one needs to be just raised up because it's not quite straight. Too approximate, too bending. Okay, that's better. So, okay, 1 goes in here once, twice, and not quite a third time. And we're taking this one once, twice, and not a third time. If we stay on this higher level here, how is that? Overall, it seems to be all right in terms of the direction, the perspective, right? All right, so that means I have the center, and I'm jumping a little bit more ahead. Where's my 90 degree, right? We need to establish that 90 degree. I need to see that 90 degree angle. How is that? This is 90. Or is it still, I feel like it still could be a bit more like this, right? Mm-hmm. So let me lighten this up so it's not too confusing. Let's go a bit more this direction, and a bit more in this direction. Remember that compared to this vertical, this distance and this distance are almost the same. Minus a little bit of a foreshortening, because this is looking down, means slightly, just a tiny bit away from us. More further away. Alright. That means what? This will be the highest portion of my visible cylinder shape. This will be the lowest, right? Mm-hmm. This will be this side, touch down inside this box, and this is going to be our one that we lay out that curvature. This is our symmetry for the width of the cylinder. We are imagining it, seeing it this way, plus a bit of foreshortening added, because it's going away in this direction. And then this goes here, goes here, here. All right, close enough for our initial sketch. So look how the side of the cylinder is starting to be very close to the lining up with the center. It's perhaps just a tad lower, but basically we're borrowing the same direction. That perspective line works for us. Here we go. This will be our bottom of the cylinder. We can extend it lightly past this, and that means that our top of the cylinder, this is the last visible portion.
Yeah.
Everything here is below the curvature. That means this is not as high. It has to come down a bit lower, which gives us a better proportional distance over here. And now we can compare our perspective angles. All right. So if we have this strong angle here and this one slightly dropping, now we copy that, come up here. It's slightly dropping, but it could drop a bit more, just a tad. So that's what I'll do. I will shave off a little bit more here and connect it to here. And I will say this will be good enough for what I'm doing for my perspective.
Can I take a pic? I want to start taking pictures of like steps. Kind of.
Yeah, but you can also watch the entire video later.
Yeah, because you're going to publish it, right? Yeah. I just want to just...
You take whatever pictures you need, ask whatever questions you need.
Yeah.
Alright, so again, I'll extend this through because we are concerned with the back. How do we know where that stops? We know because I see that actually it starts curving like almost like here.
Mm-hmm.
And to double check, I'm actually gonna go to the cylinder and see just how far behind the cube it is.
Mm-hmm.
This is the back end.
Yeah.
And it's fairly close to this edge.
Mm-hmm.
And do you see any of this?
I don't see any curve.
Where I'm touching?
No, I don't see.
You don't see it from my angle. So that means it goes just a little bit behind, right?
Mm-hmm.
So that means it's doing something like this, right?
Mm-hmm.
Similar to this, but over here. And if that is the case, here's what I'm going to do just for the sake of study. You stay right here in my spot. You look at the cylinder and the cube. And I'm going to put this here. Where does it intersect the cube?
It's like in the middle of the back.
Okay.
Back.
And that is where the cylinder ends. In the middle of the back?
Mm-hmm.
Kind of like this?
Yeah.
That's what you saw? Okay, then. That means we're close. Look at that. Here's our edge. That also means that this is going to be the box, the rectangular prism. So now we don't even need to do it super precise. We found this corner. We just need to hit it close enough to go in the same direction as all these others. A little lower. For our perspective. This one, this one, this one. Something like this it's doing. And so now we found the close to us edge. Now we can find the back edge. Just close enough again. Allow for a little foreshortening. That means this is the bottom of your rectangular prism into which the cylinder fits. This is its back. It's gonna go up. But this is all we need. Right here. This is all we need for this drawing. We got everything else lined up according to all the rules. We got this and this in sync, the angles, the perspective. We have this almost constructed according to our rules of cylinder, and therefore all we need to know is this is back here, this is the back wall. We don't even need to finish the top. We don't need to do that because we found this corner. And this is the most critical corner because as long as we fit the back over here, and since it's beyond the cube, we don't need to finish drawing it, we know that our back of the table can't go any lower.
Yeah.
Right? Because also that this part of the elliptical part of the cylinder will be touching down right in here, and this can't go beyond the wall. It will bump into the wall. And if you want to look and see, there's actually, I can put my hand between the cylinder and the wall. Easy.
Yeah.
Right. So there is space. Which means if the cylinder was pushed against the wall, the back wall, being about this angle, would be right into the corner.
Yeah.
But it's not. Means we are raising it just a little bit to allow for that extra space. So now I'm seeing that where I sketched it still kind of stays true. The angle, I can transfer the angle because I pretty much see that box, not the box, the wooden wall, right? I see the angle of it. I can transfer it here. I can make sure it doesn't hit the corner of the cylinder, and it comes out here. And it comes out here. You can connect it completely, obviously. Make sure it's all nice and straight and doesn't change angles. Because if this goes this way and this suddenly comes out this way, the table is warped, right? Either the table or the wall are warped, but we can't warp them. It's lower here, lower here, lower, lower, like that. Okay. Good. So all the lines can be tightened up later, but the main thing is we're in the clear here. That was critical. Now the front of the table, let's make sure that the front of the table is in perspective with the rest. If I leave my edge of the table right here, it seems like I've got more or less good perspective from my edge of the table. Well, actually, now that I'm seeing this, no, it's opening up this way. So I need to do better than this. It needs to be dropping. Where is it gonna be dropping? obviously we can drop it this way, or we can leave this the same, and no, we can leave this the same and raise this, or we can leave this part the same and drop that, right? So that will be determined by this distance. Now you can go in there, and I know it's not too sharp, but you can approximately see the main change. Compare it to the height of your cube, and it seems like this is a third. Fits in here 3 times. So I have it a bit too high. I'm raising it. So now I see this as being 1, 2, 3. Now it's too much. Okay, let's lower. Do it more like this. 1, 2, 3. Now it's closer. Now it's almost 1, 2, 3. Here we go. So this is my boundary here, and now I'm getting this angle. I'm bringing it to my boundary. I'm keeping it on my boundary, and I'm adjusting it for perspective. This dropped, this raised, it went through this. Guess this was the critical distance, right? Yeah. Okay. So it's going to be higher here. It's going to be lower here. It's going to go through here. And now you can compare to the wall and table connection. Here's my background. It's coming here. Could drop a bit more. Let's focus on the lower end of this. More like this. Now you staked out all of your main shapes. You got all of your proportions, everything figured out. So now we can clean things up. We're cleaning up only the things that are not critical for us to see while we're shading, right? And I won't clean up like super all the way, so you could still see it while you're drawing. But this way, if I clean this up slightly, you will see better the main shapes, the main balance. Alright, this needs to be more visible, this more visible. And now that we have that, you can sharpen up this. The next step would be to tighten up all the lines, make sure they're all nice and precise. And let's add our shadows. We know that all of this is going to be in the shadow. We're going to separate that and immediately push it into a very light value, but it's definitely darker than the white paper. We're going to position this here. Again, if you want, you can just transfer the angle of that shadow. Comes out this way. It's curving. How much of it we're seeing? It's curving. It's curving, kind of coming down, almost crescent shape. Under, almost blends with the shadow that starts forming here on the edge. There is all of this obviously in the shadow. Even though you're still going to tighten up your lines, this is totally fine. Just sketch this in like this. And then we're going to work on making this better elliptical. We'll throw in this shadow here. It starts right at the corner, but where is it heading? It's heading to connect with this shadow. That means if you're looking at it and you're seeing more of this stronger angle, that means that this perhaps needs to be extended a bit more. You can also compare the distance that you're seeing, how much of this and how much of that. There is a tiny bit of a shadow underneath. And that shadow goes right onto the cylinder where the touchdown is. And it follows a different angle. It doesn't follow the angle of the rectangular prism it fits through, but it has a bit of an angle of its own, and in a way that angle is similar to this angle, because both of them are being cast by the same type of edge, vertical edge. So, alright, so this angle and this angle of the cast shadow are going to be pretty much the same. Where does it stop in there? Just compare it to the edge. Where does the shadow hide behind that edge? The fabric is kind of rough, but I'll simplify it to the shape now, right? Okay, the only thing I think I might want to make this a bit more here and a bit more curvy here, like that, I think, for now. This is where it's starting to get also dark, and the darkest is the cast shadow on the table. Alright, and so the rest basically is over here is kind of background. Some of it is more shadowy than the rest, but I will separate the background from the flatness of the table real quick. Okay, so now we staked out basically what our still life is going to look like. Did you catch what is wrong here? It seems that I drew everything according to the rules of perspective, but there is one very important point I'm trying to make here, and if you caught it, you aced this lesson and you can proceed to drawing all other still life. If you didn't catch it, that's okay too. This is why we learn. We need to make mistakes and learn how to correct them correctly. I have a surprise for you. When I was drawing this, did you notice anything odd, out of ordinary, or anything, any concerns or any like questions in whether in the open or back in the back of your mind?
For now, no.
No?
Mm-mm.
All right. So if you didn't notice, that means you still didn't fully grasp all the main points of how to get to this stage, right? So here's the thing. What is this line?
I'm not sure because it can't be perspective because a perspective is way up.
Yeah, but this is our, or my original boundary for the cube.
Yeah.
Remember now?
Yeah. The original.
So what is off?
It's shorter than the original.
It's shorter than the boundary I established for it, right?
Yeah.
So that means that something hasn't been constructed, well, construction-wise it's solid. What had been omitted is that particular part of the proportion, right? And in light of how I helped you fix your cube, how do you think this should be fixed?
Well, Since the original was this high, that means, well, compared to this one too.
Yeah.
So either have this one a little smaller, so that it matches with this more, like here, have this a little smaller, so that the difference is like the same as before. Or you can just make the cube a little larger, but I don't know if that's the case from where you are.
But think what it means, because width-wise, the proportions is still the way that we measured originally, right? Even this is still good, right? So where the lowest portion of the cube is compared to this. But what this particular point, that boundary, meant, it meant this is how high this part of the cube comes to, right? And remember, we were measuring this part?
Yeah.
I was explaining why this is there, right? It makes this top opening, how much of it we're seeing. Remember, I measured it out proportionally to be 1, 2, 3, right?
Yeah.
Okay. So if it is now a lot smaller, that means what?
Maybe originally it was too large. Because since now it fits better.
But that's what I measured, right?
Yeah.
So the proportion was good.
Yeah.
Because we laid it out according to all the proportions. That means that the perspective head is drawn stronger than what we see.
Yeah.
Stronger in what way? It's as if I'm looking at it from like the cube and the cylinder a little higher than what they are.
Yeah.
So here I'm looking way more down, and here I'm not looking quite as strongly down.
Yeah.
So one reason it may be because I have this camera phone in the way, right? And every time I was drawing, I would step back. That changes my angle of observation. But when I was laying this out closely, I was still looking at it, stepping up closer too, right? All right, so the thing is that you need to start catching on to this. If you see that I'm laying out this proportion, and this is the boundary for the cylinder, you catch on to the fact that something has to touch this, right? One part of the cube. So much like what I did with correcting your cube, what it means is that this is a bit lower of the angle, and I need to increase it, so I would be looking more down, right? What I don't need to change is this proportions. I don't need to change the position of this. I just need to increase the strength of my perspective for the angle of observation. Okay? Once I increase that, this will increase. Basically, they will rise a bit, right? And when these lines rise, they will start to more readily intersect with here and with here. So here's what I'm going to do. So I'm going to first focus on this intersection here and focus on my angle of observation. So also I need to move back in the correct position here. So let's go. So I am going to now carefully transfer that angle and see I'm increasing it.
Yeah.
I'm increasing it at the top because the top is more critical right now. So I didn't want to go too far into the drawing until we catch on to this. This increases by a bit. It doesn't increase by much. And this doesn't increase by much. Why?
The perspective is more higher on this one.
Right.
Even if you just look at it.
For shortening and that vanishing point, it's much closer to here than for this side.
Yeah.
Because of how strongly it turns. The stronger this turns, the closer the vanishing point. If we transfer this angle, vanishing point would be within reach here. All right. So I'm not going to commit to it totally yet because I am still adjusting everything. All right. So that means that right here, it's coming up a little. Right here, it's coming up a lot. And if we have this angle here, let me check that again. That's good, okay. And check that. That's better. So if I now do this, it seems to be good perspective. But I'm still, it seems that I'm probably still not close enough to quite to here, right? And this is where I guessed it. It's starting to be close, though, and that's good. That means we increase this just by a bit more, because all we need is a very small rise. Increase it by a bit more. And increase this, but by like a split of a hair, basically. Not very much. Because when you do your side measurement, when you're figuring out your proportions, you got to know you can only come so close. You cannot 100% count on it. You have to make strategic decisions and logical decisions based on the knowledge of how it actually all works. And it's your theory coupled with your observation, with transferring all these angles. You start with where it's close enough to where it starts to be more and more what you need. And your final comparison is obviously by eye. All right, so now we have this. It should be something like this here, right? Let's get that angle over there and bring it here. Okay, the way I sketched it is actually very close. Let's just extend it to see how that perspective is starting to come out. So what is happening now? It's now starting to get close to where it's hitting this part, our boundary. Okay, I don't like how it's a bit archy, so let me go ahead and straighten them out better. No arches. Okay, that's good. Much better. Okay. Somewhere in here is where we need it, right? So remember, even this was not super precise, but it was close enough. Now our perspective is going to tell us exactly where it has to be, plus a little drop. Looks like we're good. So if we just connect this, and I extend it beyond, it's starting to work out. Perspective is happening. This intersection is hitting it in the right place. The cube is still looking like a cube. What is happening is that it's like now we see more of the top. Okay. Now, what is happening here then is not the correct perspective, right? But this is working out. Okay, so also I can check how this comes down, where it comes down, and I'm having this distance here. And from where I'm standing, it looks about right, because I see that this is not too far from here. From your angle of observation, it was a wider distance, right? That means you were standing a little more to the left.
Yeah.
Okay, so we have this. Now let's get the other angle transferred. It's much stronger. Okay. Kind of like this. If I extend this, so this seems to be like a good perspective, but I want to make sure I don't overdo it. Mm-hmm. You see how quickly it's getting closer together, right? So what I want to see is just some kind of comparison. Let's do this. If I extend it right here, for example, that's almost straight. So if I extend it, I will have this comparison here. So I want to make sure that the rate at which this is all getting closer together is the same, right? Well, actually, I didn't really need it unless I extend this. Let's compare it. How is this going away? Is it too extreme? Let's compare this distance here, from here to here, right? To how it goes in here. It's almost 2. Mm-hmm. Let's take this distance here, compare it to the side. This is where it should be. It actually should be even a little stronger than I sketched. Because we're pretty sure that we laid this out correctly, right? So just a bit stronger. Just for fun, let's see this distance. Also, 1 to 2. Yeah. Cool. Yeah. Very good. So that means I don't have to worry about this anymore. Now we need to get this side correctly. All right. So just for fun, I'm going to look at this, bring it more or less parallel. Definitely needs to be stronger, but then it has to go even more, right? So it's going to be something like this. So now I'm going to look at it and transfer it. Yeah, it's about how I was guessing. More like this. Extend and compare it to here visually, right? So now see how it definitely looks like we're looking more down at it now. Sure. Mm-hmm. That's good. So before the cube was constructed correctly, if nobody saw the actual still life, they would not know the difference. Yeah. But we know the difference, and we are training to know the difference, right? So now the cube maintained the same proportions, and it's the correct angle to what I am observing from this particular point, right? So what does it mean for the cylinder? How do we make sure that this has the correct angle of observation, right? So for example, this proportion is still maintained the way I did it before. So that's still good. This width still comes in within a little bit of this shadow. So we're keeping all of that. the cube still the correct proportion to everything. We need to make sure that from this particular angle of observation, this elliptical shape looks right, right? So what, we got a little bit more of an increase here, which is a bit better for what I'm observing. I'm going to double check my angle here and the bottom of the cylinder. Looks like it could be fine, or could be raised just a bit. In a way that makes sense, raising it a bit, this perspective, this particular perspective. Why? Because if this became a little stronger, and remember, the cylinder was not parallel to the cube, which if it was parallel, it would fit within this, all of this perspective. It would be very similar. But it is not, so it has a little bit of an angle compared to the sides of the cube. By the way, the other sides of the cube are going to be more like this now. Even more observable space than here, right? Okay, so here we go. This is all adding up nicely. This perspective is adding up nicely. This is still coming short of the wall. The cube is not against the wall. The cylinder is still not against the wall. We just want to make sure that we change that little bit of an angle, making it a bit stronger. That means we need to make sure that this is not too extreme of the perspective. Just raise it a bit, which means that it's giving us a little bit stronger angle of observation, and it connects to the angle of observation on the cube. So this is all good. Final check before we go into all the construction details. Somewhere in here is going to be our center. If you are not sure how to find that center, because of the foreshortening, you know how this could be quite a bit more than here, right? It could be mild, it could be more. What you do is you look at your elliptical and you put your pencil to where you think is the lowest touchdown here and the highest possible elliptical part here. You're going to look at it. On the top, for example, it's easy because there's so much light here. It's very strong light. And you can see that this light gives you this part of the elliptical very clearly, where it comes up the highest, for example. And then it goes down. So I'm looking at it, I'm seeing like it's something like this. Then where is it the lowest? Right down there. And then I'm looking for that center, and I'm seeing like it's not very strong for shortening. So here it's just a little bit more. And compared to the center, this foreshortening is not very extreme, not like we practiced with the vanishing points. All right, so now we need to find our, this is going to be our center. Now we need to find our, horizontal center with the perspective. So if right up here it comes over here, and down here it comes right here, this is our touchdown, then we need to make sure that this is exactly in the center. Let's see, is this in the center now? Yeah, okay, we're keeping that. And now we need to make sure it goes within that same perspective as we did for our possible rectangular prism into which it fits, right? I have this line here, I have this line here. This needs to fit right in between, just the right way. So if this is exactly half and half here, then it has to be exactly half and half here.
Mm-hmm.
If it's not, that means it's not going at the right angle. Okay, now it's good. So this is it. Has to go through the center, has to go beyond, and up here. Let's see, how's this working? A little bit more precise here. A little bit more precise here. All right, goody, goody. So now, even this is not important anymore. Not all the way here. We can lighten this up because we got our box. If you got your box, you got your back of the box. You can do it fairly approximately. Here, here, where it ends, somewhere in here, right?
Mm-hmm.
We just want to make sure that it doesn't hit that back of the table. That's what it is about. We changed the angle just a little bit. We want to make sure it doesn't hit it, okay? So if it was here, it will go more like this. And somewhere in here it will intersect with the back. And it still misses the table.
Mm-hmm.
And that's good.
Mm-hmm.
All right, so everything is nice and sound now. Now we fill in this, your rotational center. Give it a bit more precise line. That rotational center needs to fit neatly between this line and this line. The bottom of the cylinder that we see, the top of the cylinder that we see. Now, the center of the cylinder comes right in here. The other center comes just a little bit below here, because this is the line that is the edge of the cylinder. The center is right just slightly below it. This one is just slightly above it. This fits right in between, right? So that means that now we can add that 90-degree through the center lightly, very lightly. You see how much distance there is here? It should be about the same here, right? Because it's going through the center, and these lines are nearly parallel, not completely, but nearly. All right, so that means that this is doing something like that through this side. This is doing something like that here. And if you stand sideways and look at it, this way,
Mm-hmm.
you will see that it needs to appear as if what you have on the side is your vertical,
Yeah.
right? When you're doing it vertically like this, right? Imagine that now you're looking at it from this angle.
Mm-hmm.
So That means this is the most extended part because it's that part. And this is the most extended part because it's that one, right? And the others are already starting to get narrower. And you compare the symmetry to here. This is nearly symmetrical to here. Nearly because this is already slightly foreshortened, right? And then this being your other part. And then you compare this quarter to this quarter. And if they look nice and neat, and like they are turning and all, plus it has to touch down here, right? But then it starts to already rotate away, 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 touch down here through this intersection, and then a little bit still extended, and then away, 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 touch down. And same thing here. So what you're observing is here it's less curved, here it's very curved, right? And if you are drawing arches, and your arches start going straight right here, this is how you are expected to construct the top of the arch. So here it's going to the most extended part right here, and then it's starting to curve away with a touch down here, curving away, away, with a touch down right here. You see what is happening is it seems to be stretching this way, right?
Yeah.
And that is your correct construction of that elliptical. And now that I've done this for you in front of you, you look at that side of the cylinder and you see how you're starting to really see it stretch out this way, right? All right, so what I'm going to do is I'm now going to clean up these lines. And after this, you are working on getting it all nice and neat, all the lines nice and precise. And then we start shading. We start the values. I will not erase so much in here because it's all in the shadow. Why waste eraser and time? But I will clean up everything that's in the light. And of course, since this is the most extended part, and this is where it is, right? Here's the touch down on the table, because that's where it also has the touch down within the prism, and the side of the rectangular prism is flat on the table. That means that this is your lowest most point. We're going to keep it as the lowest most. But do we see that part of the cylinder? Already not. The last part of the cylinder we see comes right to here. That's this side of the cylinder. It has to head right for this spot, for this touchdown here. And so because beyond that, we simply cannot see beyond that curvature. Now I need a harder, softer pencil, rather, darker one, to be able to achieve what I want here. Let me switch. Where did I put my pencil?
I don't know.
I had like my little one. Let me see.
I think that's one's
It's
mine.
H, yes. Well, let me just use, there it is, I see it. Okay. All right. Okay. This is that little bit of a shadow. And what is happening with the shadow? It extends a little bit here, and we see a little bit of it in front of the cylinder. It's kind of wobbly because the fabric is wobbly. Okay. Okay. So the cylinder goes in here, and this is all the shadow. Of course, this is all going to be darker values, so I'm not too worried about it. I just want you to see the more precise drawing. Like that. And on top, clean this up nice and neat, make this line nice and straight. This is where it touches down. Actually, why bother erasing? All of this in back is going to be a darker value. Not by a lot, but darker. So I'll just fill it in right now and make that already disappear. All right? Mm-hmm. Okay, so sharpen these lines now, start sharpening all of them. Make sure that all of your straight lines are straight. Clean up all of your guidelines. In this case, in this drawing, if you see some because you just can't erase them, no big deal. Mm-hmm. But erase them as much as you can. Mm-hmm. Because now we are focusing on values and not construction. It is totally fine if some of them are still showing through your drawing, because we're still learning. It is not the goal to make it so super neat that it looks like picture book perfect. And in our art school, if you had a good solid drawing and some of these construction lines were showing, the teachers didn't mind at all. They just were like, instead they were admiring your construction through your already shaded and finished drawing. Mm-hmm. Just shows that you know what you're doing. Okay? Overall, we'll still achieve the needed effect. How could we do that? Because the true white, the true highlights in all of that is going to be just a little bit on the very edges, little bit. There's going to be hardly any white paper left everywhere else. Mm-hmm. Because of that, the fact that we have already all these lines in here and we can't erase them all is completely not a big deal. Okay? All right, so I'll just sharpen this before we finish up so it's more visible. Okay. All right, so as you can see, it's too tall compared to how high it is. So when I'm measuring side measurement, I see that this width should be a greater distance than the height, and you have it the other way, right? But before we start widening the cube, or maybe we need to shorten it, we need to figure out which way it would be better. We can't just deal with it by itself because it's in the composition with the cylinder. And we have to take into account what is happening with the cylinder. So that means that I know that the cube definitely needs to be wider than it's tall, but what do we first shorten or expand, right? So I'm going to, from this position, this is about where you were standing, I'm going to measure the cube width and compare it to the cylinder. And I see that the visible part of the cylinder is definitely less long than the entire width of the cube. All right, so the entire width of the cube is longer than the visible part of the cylinder. You have it almost equal plus a little bit in here, right? Okay, so that's one issue. So width compared to the cylinder in composition with cylinder looks like it could be moved, right? It could be moved a little bit more this way, which will give us more width. Now I'm going to go ahead and measure the whole height of the cube and compare it to the cylinder. Not the height of the cylinder, but the width. And I see that when I measure the height of the cube and compare it to the cylinder, that too is a lot longer. It comes in more this way and actually is closer to this edge here. Okay? So, all right, so that means that we can definitely widen the cube.
Yeah.
Not shorten it, but widen it. And if we are also comparing what is going to be happening with the cylinder here, it looks like we have enough to come for the cylinder and hide behind the cube right around here, right? Mm-hmm. All right, so that means now we need to widen it just enough, right? So remember how I said when I was measuring the width of the cylinder was actually a little bit longer, right? A little bit greater distance than the height. So I'm gonna now measure it again now that I know what I'm changing. And I'm comparing it to the height of the cylinder. Why am I saying cylinder? The cube. Okay. Cube is this wide. And the cylinder is, it's coming to, so this coming over here, it's supposed to be slightly wider so they overlap. So if I add this much width to my cube, and now I compare that to here, now they're overlapping, right? Are they overlapping enough? So this part to this part now need to be adjusted because they are definitely not that kind of proportion. So I'm going to measure it again. I'm measuring the shaded part of the cube compared to the side of the cube that's fully in the light. And it seems like this side's proportion to the shaded is almost 2 to 3. Almost, but not quite, right? That means this edge is also moving. If we move this edge over here, right? We move this side over here. We move this one over here. Let's measure this side proportion compared to here. 1, almost 2, but still space left. It wasn't like this when I was measuring. It was closer to being one measurement fitting into that side 2 times. Plus a teensy weensy a little bit more, which means we can, and by the way, this one is overlapping here, so that means we can move it just a tad more, just a tad, not much, and we can move this just a tad more, adjusting for that proportion. We can take this measurement, fit it in here. Okay, that's now good. Now it's like 1 fits in 3. 1 fits in 1, 2. So 1, 2, 3. And now if we take the entire width and compare it to here, now they are overlapping pretty good. See where it is? The overlap, right? And this is your new edge. And if you go back here, again, take a look at the entire width of the cube, compare it starting at the cylinder. It overlaps, and actually the overlap is even stronger. It's a bit closer to this side. All right, so before we do any more changes, let me have the eraser. I'll clean this up a bit so we're not confused by the old lines. So before we do any more changes, we now need to make sure that this width is okay with the height, right? And now it is a teeny bit longer, right? A teeny bit greater distance. Okay, I'm gonna measure it once again and see if that's the proportion I saw. Yeah, it's pretty close. So here's one width, measuring up. It's pretty close to being just a teeny bit taller. Okay, so looks like we can keep that, but we may want to move this slightly over again and fine-tune that proportion further. So if this is slightly narrower now, and it will fit in here once, twice, and then now we're gaining that little bit extra, right? That little bit extra side, little extra space. So perhaps that was a bit extreme, so let's not push it too far. So that distance here, that little extra, wouldn't be too big. We'll perfect that. We'll perfect that. A little more close to what we want. All right, so let's lighten this up so it's not confusing. And lighten this up, right? So that means that if our cube is fitting within this parameter, but the width changed and this moved, then these lines also, they have to move. So this is still our bottom, lowest portion of the cube, right? Now let's see how it will work out. If we start moving that and go in this direction, what kind of angle does it have? Your angle is pretty close, but it could be just a little bit stronger. So you can keep this angle, but perhaps give it a bit more turn. If this becomes our touchdown to the table, and your cylinder is here, this is the rectangular prism, except it's not going to be straight on, obviously, right? It's going to be at an angle. All of this is going to change from a straight on square to a square side in perspective, right? But I mentioned that from here to your elliptical, it still seems to be working. This is still a good rise. This is still higher than that. So that seems to be all right. The cylinder will still go behind the side of the cube. It's not going to clash with it, even though we moved it. But now this got a lot shorter, right? And yours obviously was longer, and the visible part of the elliptical side was narrower. So I'm going to measure the elliptical side now and see what it's doing there. It's almost like the elliptical side fits in here 1.5. This is basically 1. That means we have to shave this off. Take this as 1, close to a half, but not there yet. Move it just a little bit. See, we're not moving this boundary. This stays. We're only moving this. Take this, measure it in here 1, and now it's close to being 1.5. Okay, so that got moved slightly. So that means the cube seems to fit. That means this side needs to be moving over just a little bit. This is your approximate how it's going to move. And let's see if this is still going in the same direction, then likely this is gonna work, be very, very close. So the only thing we have to now watch out for is that this becomes higher, right? So if we start going in this direction, we miss that boundary. We go above that boundary, right? That means that this side needs to be lower. Let's see if we can, for example, keep this and just bring it over here. What does it give us? It gives us this intersection. Okay, that intersection is very close where I sketched it. Very close to what I sketched. Kind of like this. If we are maintaining the same perspective here. So let's check it out. Approximately. That means this side is moving, but we are keeping the same incline. So we are maintaining that perspective. And if we are keeping that wherever this intersects, you need to straighten out the side, by the way. It's a little leaning a bit. So then we'll go from here. So again, this becomes too high, right? A bit too high. So that means that we need to change our angle of incline just a bit and perhaps lower things just a bit. So if we lower it, because you see how we're missing this, right? We want to keep it within this boundary, but if we go right in here, then it starts to go too high above it. Unless, so this is still your perspective. Now we're focusing on this one, unless we bring this and intersect it over here. But what does it give us? It gives us this distance that is too short compared to that. It should be the opposite. You see? That means that the things just don't quite add up. This moved, so how do we make it add up? Let's go back to our boundary right here. Let's clean this up. And we'll go back to our boundary and compare if this is what we need compared to the height. Right? It's very close. From this angle of observation, I see 1, 2, 3, like 3 at least, and maybe just a little shorter than 3, at least from this particular position, right? That means that we need to lower this point. If we lower it by this much, will it give us a better proportion overall? 1, 2, 3. Now it's getting close. We can probably lower it just a tad more like this here. Let's take this proportion. 1, 2. Now it's better. It's almost 3, right? So that means we need to adjust everything here. One thing's for certain, this stays, but how do we achieve the top of the cube fitting within this distance, right? It has to be just right. So it has to be, like, by the way, it looks like this perhaps is almost what you need. So we can keep that. That means this is going to go in this direction. This is now going to be lower. And this one, if it's going here, it has to go in this direction and also intersect in the proper place. So if we're changing all of this, I can already see that this doesn't quite add up. It still is coming up short if we are to fit it within this distance here. So what you can do is you can take this, compare it to here, and see that it has to be slightly wider, right? So this point here definitely has to move. But if this point is moving in this direction, that means that this angle is becoming steeper, right? The steeper angle here means we are looking considerably more down at it than what you drew right now. Like this is as if the cube was a little bit higher. But if this angle becomes stronger, then these angles have to become a bit stronger as well. And this has to become a bit stronger as well to accommodate for that opening. All right, so we will increase the steepness here. Let's just think through this problem, right? I need you to think through so you could make the connections on how all of this is working. And then once you got it figured out, you will never make the same mistake. This rises. This is now almost falling over here on this line, which kind of worked before. But we also need to make sure that the bottom is, right now it's like too much of a parallel. We need the perspective. So I'm measuring that line, I'm measuring the bottom, I'm bringing it here, and I see that it's a bit steeper, right? So this was parallel to your old line. Now it becomes a bit steeper. Okay. So instead of going lower, we'll go a bit higher. Let's get rid of that as well. So now compare this to that. There we go, right? So there, that looks like it's pretty close to what we need. All right. So this one got moved. That means this now has to also somewhat increase, right? To what degree? Let's measure the cube, bring it here. It's pretty close to the old one, but maybe just needs to be a teeny bit steeper. And I can see how it really doesn't need to change too much. Because if we see more of this side, that means we are observing it at a less steep of an angle to us, right? So straight on is a full square. When it's turning and not quite a full square, it means that angle changed, but not by a whole lot. So one other thing I do want to change before we go too far, not change, measure before we go too far. Okay, see, this is good. This is just a little bit taller, a little bit more measurement than this one, right? And that's to accommodate for shortening of the perspective. So that also is making logical sense. So straighten this out a bit. So now I think this is better here. I shouldn't go too far to that side. So just need to straighten it out. Okay. That's straighter. And now we need to see how this intersects here. So if we made this a teeny bit steeper, we bring this up here. There's also change. That's good. That's good. So pretty much this stays. Then we're aiming somewhere on this line here. From this corner moved just a teensy bit. So this is the angle. This is if it's completely parallel, and then a little more adjustment for perspective. I will also just look at my actual cube, bring it here. All right, so definitely needs to go more up. Check again. It's dropping. Okay. So now let's check this side. Let me just get closer here. Check this distance and check this one. It's increasing. So we're seeing a little bit more of the back side here. We just need to up this a teensy a little bit. And then that means we bring this more like this, and it gives us this intersection here. The other thing you can compare is right on the cube. You can look at how this side, when it's projected up, compares to where this is, and the distance between the two. See? So what I'm seeing is this: if I bring this up like this, and if I look at this one here, what is that distance? And how wide is it, right? I'm looking at this. I'm seeing that it's pretty hefty. It's not all that little. It's almost like 333. And this is close, very close to what I'm seeing, right? So at least in this change, it seems to be working out not badly. I would just say like this is kind of moving up a bit. Let's straighten it out. Perhaps it needs to be just a teeny bit lower on this end here, so it would look straighter. And that can actually lower this and then further intensify this angle here for us. That will be your back. Make it a whole bunch straighter. All right, so I'll let you clean up the old lines, solidify a little bit your perspective lines, and then we will start fitting in your cylinder, right? But there we go. So I was actually, it's good to make this mistakes. I'm always glad to correct this, because students will be sitting there struggling with it, and if you don't show them how to correct it, you can tell them that this is where you're off, but if you don't show them how to correct it, they'll be like usually going for correcting the wrong thing. Like, oh, it looks too tall, let's shave it down. But then your proportion to this changes, and you can't just lower all of the top lines. You see, so it's good. Let's see how this comes out when you clean up all the lines.